All right, AP Calc students, welcome back for more FRQ review. The problem we're looking at today is 2018, number 5. So this is a non-calculator question, and this falls under the category of what I call potpourri. They just give you a function, and they ask you all sorts of calculus questions in a very skill-based way. And so the only given information actually is the function. And then can you manipulate it with all the correct vocabulary, and do you know exactly what they're looking for? So typically on these questions, in AP Calc, you only learn how to do 3 things. Take limits, take derivatives, and integrate. And so all the questions have to address those 3 skills, and they may just ask them in kind of a little bit of a cryptic way. So let's see what we've got here. It says, let f be the function defined by f of x is equal to e to the x cosine of x. So the function is a little bit complicated. I'm going to write that over here. And this is the thing we have to play with here. So e to the x cosine of x. Now let's see what they decide to ask us. So part A. Part A says, find the average rate of change of f on the interval 0 to pi. Well, it doesn't get much more straightforward than that. They want AROC? Well, that's a really easy question, assuming you know the vocab. And so you should know AROC is the slope of a secant. It's Algebra 1 slope. This is actually a very easy question, but a lot of students don't know their vocab. So it's just AROC, and the interval they give us here, they want AROC over 0 to pi. So you guys should know then. You should say, okay, well, looks like I have to do f of pi minus f of 0, and then I'm going to do, those are my difference in y, and I'm going to do that over pi minus 0. And if I know how to evaluate these values in my function, I should be fine. So we'll put the work under here, and so I'm just going to figure out what f of pi is. So f of pi is equal to e to the pi times the cosine of pi. So we got a little unit circle that we need to know. So let's see, we're obviously here is 0 and 2 pi, and here is pi. So the cosine of pi is -1, and e to the pi is just e to the pi. So this is equal to negative e to the pi. And let's figure out f of 0. F of 0 is going to be e to the 0 times the cosine of 0. Well, the cosine of 0 is 1, and e to the 0 is 1, so it looks like that just equals 1. So it looks like my numerator is going to be negative e to the pi minus 1, all over pi. And that's it. It's actually just a 1-point question. So this was the average rate of change over the interval, e to the pi minus 1 over pi. And it's not unusual with this kind of question, you get weird-looking answers like that. You don't have a calculator, it's the best you can do. And actually, it's more accurate than the decimal approximation anyway. All right, B. What is the slope of the line tangent to the graph of f? Well, this is testing you on whether you know what's a derivative. Derivative is the slope of the tangent. So this is saying, what's the slope of the tangent of that function, and they give you the x value. Another very easy question if you know your vocab. So we need to find f prime. And so we have a little product rule we've got to do. So the derivative of the first is e to the x times the second plus the first times the derivative of the second. So there's that. And then we have to evaluate it. It says at 3 pi over 2. So f prime at 3 pi over 2 is going to equal e to the 3 pi over 2 times the cosine of 3 pi over 2 plus e to the 3 pi over 2 times the negative sine of 3 pi over 2. Negative sign, that is. So let's see what we got here. So these e values to their exponent stay the way they are, but the cosine of 3 pi over 2, that's going to be down here on the unit circle. So the cosine there is actually 0. So this entire term drops out because it goes to 0. And the sign at that value is actually -1, but it's minus a minus 1, so it's 1. So the entire value here simplifies down to e to the 3 pi over 2. And that's it. That was A, that was B, we're halfway done. All right, part C. Part C says, find the absolute minimum. Well, once again, a very basic skill in calculus. When you want to find an absolute min, what this should be making you think of is better find your critical numbers. Because we're going to take our derivative, set it equal to 0 and undefined, and get our critical numbers and then test them. And so first we have our derivative up here, and I'm going to move my work here because we're running out of space. I'm going to move my work up here to this side here, and let's see what we have. So we will let's get this out of the way. And just so we have it to refer to, let me rewrite the original question right here. So f of x, or the original function that is, e to the x times the cosine of x. That's our original function. So up here, we're going to take our derivative, and yeah, I think I'll have enough space. I'll go ahead and rewrite it anyway. So the question is, find the absolute minimum of the given function, which was e to the x cosine of x. So your first step is take the derivative. Well, we already did that on part B. So if you guys notice the derivative here on part B, I'm just going to factor out the e to the x and clean the derivative up just a little bit. So I'm going to say f prime of x is equal to e to the x, and then I've got cosine of x minus the sine of x. All right. So critical numbers mean I take my derivative and I see when it's undefined, and I also want to see when it equals 0. Well, this function is never undefined. There's no denominators and no discontinuity we have to be worried about here. So it's never undefined. That one's easy. And then we have to set it equal to 0. Well, we have a product here setting equal to 0, so I'd say, well, I better solve for when e to the x is equal to 0. But then I also have to solve for when the cosine of x minus the sine of x is equal to 0. Those are the two things I got to solve for. Well, this e to the x equals 0 right away, you might recognize that there's no answer here. This will never be 0. But if you didn't, you could actually take the natural log of both sides, and this would turn into x natural log of e is equal to the natural log of 0. Natural log of e is 1, so I just get x is equal to the natural log of 0. Then this might trigger your memory to say, oh wait, arguments on logarithms have to be positive. This is undefined. No good. So we have this is never true. So we have no values from this side. So nothing here, and we have nothing here. But this one is definitely doable. So when does cosine minus sine equal 0? Well, that's when cosine is equal to sine. And that's a pretty common knowledge from pre-calc. You'd say, when are sine and cosine the same? Well, at pi fourths and at 5 pi fourths. So there's your critical numbers. And you just want to double check that the domain on this question was 0 to 2 pi. The first part, it was only 0 to pi, but this is 0 less than or equal to x less than or equal to 2 pi. So I do get to use both of those values. So there's my critical numbers. Now, if this question would have been asking about increasing and decreasing, you could have done an interval test, but the interval test on this one is not necessary. And the reason it's not necessary is that the question is asking for absolute. And whenever you need an absolute, you could test your intervals and it could give you some hints at what might be a candidate, but it's actually more of a time waster, and it actually you could potentially make a careless error in here. So doing an interval test, not necessary when it wants an absolute. Just test your critical numbers and your endpoints, see which one's the smallest, and you're done. But if you like doing this, go ahead and do it, but I'm not going to. I'm just going to say, well, I need to figure out what is f of 0, and then I need to compare that to what is f of pi over 4, and then I need to compare that to what is f of 5 pi over 4, and then I need to compare that to what is f of 2 pi. I have 4 things to check. Smallest one's the winner because it's absolute minimum. So f of 0, well, there's the function again up there. And so this is saying, all right, well, what's e to the 0 times the cosine of 0? And you can say, well, e to the 0 is 1. The cosine at 0 is 1, so this is equal to 1. Done. Pi over 4. Let's put that one in there. Well, we get this very ugly e to the pi over 4 times the cosine of pi over 4. I'm like, well, that's pretty ugly. It's rad 2 over 2 times e to the pi over 4. Now, if you're thinking right now, Oh my gosh, I have to figure out what that decimal approximation might be to answer this. That's not a bad way to think, and it's looking ugly, but it's not as bad. There's a little surprise coming up here. I'm just going to write this down a little bit lower so we have a writing more level here. All right, so now it's to 5 pi fourths. Well, this is going to be e to the 5 pi fourths times the cosine of 5 pi over 4. And cosine of 5 pi over 4 is just like this one, but it's negative. So I get negative rad 2 over 2 times e to the 5 pi over 4. Ugh, these are ugly y values. And then the last one here, 2 pi. This one simplifies a little nicer because it's e to the 2 pi times the cosine of 2 pi. And back on the unit circle, cosine of 2 pi being here is just 1. So this one just equals e to the 2 pi. Now at first this looks like this could be just a nightmare to try to simplify, but the question says find the absolute minimum. And of these four, there's only one negative, and that's this one. So it's got to be that one. It's the only one that's negative. So I'm going to summarize by saying absolute minimum occurs at f of 5 pi over 4, which is equal to negative rad 2 over 2 e to the 5 pi over 4. And there's my answer for that one. I'm also going to make a little line right here. Separate my work. Alright, so there is that answer there. Alright, now it's time for D. So this was a continuation of C right here. And now time for D. So D says g is a differentiable function. They didn't give it to us, but they just said it's differentiable. And that g of pi over 2 is equal to 0. The graph of g prime, the derivative of g, is shown. Now I'm going to show it to you. This was on the original question, but here is a blow-up of the graph they give us. I'm just going to put that right here. And we'll refer to that. So this is given in the question, the derivative of g. Not g, but they do tell us g of pi over 2 equals 0. Then they say, find the limit as x approaches pi over 2 of f of x over g of x. So I'm just going to write that down. They want us to find the limit as x approaches pi over 2 of f of x over g of x. Well, like all limits, you always just check it to see if it's a Nike limit. Probably not going to be, but we're going to see, and then if it's not, we'll deal with it. So let's go ahead and put this in here. F of pi over 2. So the f function's right here. I have it here to the side. And so that means my numerator will be really precise here. And technically I need to rewrite my limit statement. But as x goes to pi over 2 here, we're going to get e to the pi over 2 times the cosine of pi over 2, and g of pi over 2, they told us that in the question. They said g of pi over 2 is 0. So what this winds up equaling, cosine of pi over 2 on the unit circle, that's at the top of the unit circle, that's 0. So we wind up getting 0 over 0. Now earlier in the year, when you get this, you would think, oh, it's going to be a hole in the graph, I'm going to factor, I'm going to maybe multiply by conjugates, I'm going to manipulate it. But you recently learned that there is a new rule called L'Hopital's rule, that when you get indeterminate form, all you have to do is take the derivative of the top, derivative of the bottom, and try your derivative again. So this was new vocab. I'll start this over here. New vocab here, which we said this is indeterminate. Indeterminate. Because I can't determine what's going on here, because it's 0 over 0. Well, L'Hopital's rule says when you have indeterminate form, there's 7 of them. This is the one you need to be worried about. So by L'Hopital's rule, what we are going to do is say, all right, well, I'm going to take the limit as x approaches pi over 2, and I'm going to change this to f prime of x over g prime of x, and see if I can get an answer that way. All right, so the derivative of f, we did that earlier in the question. It's back here. It's also up here under the paper, if you recall. E to the x times cosine of x minus sine of x. So I'm going to write that up here. I'm going to say, well, this was the limit as x goes to pi over 2, and my numerator was e to the x times the cosine of x minus the sine of x. And then for the bottom, g prime of x, this is where that graph came in. So g prime of x, if this is the graph, all I have to do is go to pi over 2. G prime at pi over 2, the y value is 2. So that's just 2. Now I'm just going to put in pi over 2 in the numerator and let's see what we get. So my final value here, the limit as x approaches pi over 2. So it looks like I get e to the pi over 2 times, all right, the cosine of pi over 2 is 0. The sine of pi over 2 is 1. So this is 0 minus 1 right there, I think you're getting. And then my denominator is still 2. So my final answer is negative e to the pi over 2 over 2. Okay, and we had a little lesson on L'Hopital's rule, so hopefully that made sense there. And just remember, with L'Hopital's rule, if you ever get indeterminate form, just take the derivative of the top over the derivative of the bottom, and try Nike, just see if it's a Nike limit again. If it doesn't, try it another time. And sometimes you can try this as many times as it takes, and you'll get it. And that is your justification right there that allowed you to get that. Okay, so there it is, 2018, number 5, potpourri style. And that's it. Thanks for watching. See you next time.